Now that we are done with the first term performance assessment of grade 7 in mathematics, we will now proceed to their second term performance assessment.
For the first column, we will identify the class range since the total score is 50, which is divisible by 5. We will use 5 as the class size in this data. So we have 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, 26 to 30, 31 to 35, 36 to 40, 41 to 45, and 46 to 50.
For the second and third column, we will identify the tally and frequency. And according to the given data, there is 0 students who got a score from 1 to 5, 3 students got a score from 6 to 10, 0 students got a score from 11 to 15, 4 students got a score from 16 to 20, 14 students got a score from 21 to 25, 8 students got a score from 26 to 30, 12 students got a score from 31 to 35, 6 students got a score from 36 to 40, 2 students got a score from 41 to 45, and lastly, 2 students got a score from 46 to 50. And to sum it up, there are a total of 51 students, which will be R.
For the fourth column, we will identify the x sub m or midpoint of each class range. The midpoint or middle point of 1 to 5 is 3 because the number in the middle of 1 to 5 is 3. 6 to 10 is 8, 11 to 15 is 13, 16 to 20 is 18, 21 to 25 is 23, 26 to 30 is 28, 31 to 35 is 33, 36 to 40 is 38, 41 to 45 is 43, 46 to 50 is 48.
For the fifth column, we are going to identify the CF or cumulative frequency. So first, we have 0 since the first frequency is 0, then 3 since the next frequency is 3, then 3 again since the next frequency is 0, then plus 4, it will become 7, then plus 14, 21, then plus 8, 29, then plus 12, 41, then plus 6, 47, then plus 2, 49, then plus 2 again, 51, which is the same as R in. So with this, we can affirm that our calculation is correct.
For the sixth column, we are going to identify the f times x sub m. We have 0 times 3 is equals to 0, 3 times 8 is equals to 24, 0 times 13 is equals to 0, 4 times 18 is equals to 72, 14 times 23 is equals to 322, 8 times 28 is equals to 224, 12 times 33 is equals to 396. 6 times 38 is equals to 228. 2 times 43 is equals to 86. 2 times 48 is equals to 96. And to sum it all up, the total is 1,448. For the seventh column, to identify the x sum minus mean, we have to find first the mean.
To find the mean, we are going to use the formula mean is equal to the summation of f times x sub m divided by n. And according to the frequency distribution table, the summation of f times x sub m is 1,448 and the n is 51. So now we have 1,448 divided by 51, which is 28.39215686 or 28.3922 if rounded off to 4 decimal places. So our mean is 28.3922.
And again, going back to our seventh column, to identify the seventh column, we will need to subtract each x sub m to our mean, which is 28.3922. So for the first so So we have for the first class range, which is 1 to 5, is 3 minus 28.3922, which is equal to negative 25.3922. Then for 6,000, 6 to 10, or class range 6 to 10, we have 8 minus 28.3922, which is equal to negative 20.3922. For the class range 11 to 15, we have 13 minus, again, the mean, which is 28.3922, which is equal to negative 15. Again, 3,922. For 21 to 25, we have 23 minus the mean, which is equal to negative 5.3922. For the class range 26 to 30, we have 28 minus the mean, which is equal to negative 0.3922. For 31 to 35, we have 33 minus the mean, which is equal to 6,078. For the class range 36 to 40, we have 38 minus the mean, which is equal to 9,678. For the class range 41 to 45, we have 43 minus the mean, which is equal to 14.6078. For 46 to 50, we have 48 minus 48 minus the mean, which is equal to 19.6078. For the 8th column, we will need to square each of the answers from column 7, x sub m minus mean, to find the answers for x sub m minus mean squared. So the first x sub m minus mean we have is negative 25.3922 squared, which is equal to 644.7638. For the second one, it's negative 20.3922 squared, which is equal to 415.8418. For the third one, we have negative 15.3922, which is equal to 236.9198. For the fourth one, we have negative 10.3922 squared, which is equal to 107.9978. For the fifth, we have negative 5.3922 squared, which is equal to 29.0758. For the sixth, we have negative 0.3922 squared, which is equal to 0.1538. For the seventh, we have 4.6078 squared, which is equal to 21.2318 or 2,318. For the eighth, we have 9.6078 squared, which is equal to 92.3098. For our ninth, we have 14.6078 squared, which is equal to 213.3878. And for our last class range, we have 19.6078 squared, which is equal to 3,084.4658, totaling a number of 2,146.148. For the ninth column, we will need to multiply the frequency by the x sub m minus mean squared. So for the first one, we will need to multiply 0 by 644.7638, which is equals to 0. For the second one, we have 3 times 415.840 8,418, which is equal to 1,247.5254. For the third one, we have 0 times 236.9,000 ay, 9,198, which is equal to 0. For the fourth one, we have 4 times 107.9,978, which is equal to 431.9,912. For the fifth one, we have 14 times 758, which is equal to 407.612. For the sixth one, we have 8 times 0.1538, which is equal to 1.2304. For the seventh, we have 12 times 21.2318, which is equal to 254.78 7,816. For the eighth one, we have 6 times 92.3098, which is equal to 553.85 8,588. For the ninth, we have 2 times 213 times 3,878, which is equal to 426.7,756. For the 10th, or the last one, we have 2 times 384.46 4,658, which is equal to 768.9,316, totaling a number of 4,092.1558.
Now that we have identified what needs to be located in the frequency distribution table, we will now find the median. To find the median, first we must find the median class. So to find the median class, we're going to use the formula n divided by 2. Since we already know what n is, which is 51, we are going to divide it by 2, which will be 25.5. And now we will need to find the row that has a cumulative frequency higher than 25.5, and that is 29, which is in the class row of 26 to 30, and thus 26 to 30 will be our median class. Next step, we will find the median with the given formula. So based on the frequency distribution table and the median class, the L, or the lower limit of median class, is 26. The N is 51. The cumulative frequency is 21. The frequency is 8. And the class size is 5. So to summarize our data, L is equal to 26, N is equal to 51, CF is equal to 21, F is equal to 8, and H is equal to 5. And we are going to apply the values that we gathered to our formula, and we will get 28.8125. And this will be our median.
Now, we will identify the model class, which is 2125, since it has the greatest number of frequencies, which is 14.
Now, we must calculate the standard deviation, and we are going to use the formula square root of f times summation of x sub m mean squared all over n. According to the frequency distribution table, the summation of f times x sub m minus mean squared is 4,092.1558, and the n is 51. Now, we're going to apply this to our formula, in which we will get 8.95758611, or 8.9576 if rounded of 2 decimal places, and this will be our standard deviation.
Now, we can create our histogram using a bar graph, since it is easier to identify what type of distribution it is. which in our case is also positively skewed since the curve is skewed in a positive direction.
And to summarize our findings, according to the data acquired, 51 students in grade 7 took their second term performance assessment in mathematics, which consisted of 50 items. Their estimated mean is 28.39215686 or 28.3922 if rounded off to 4 decimal places. And the median class is in the 26 to 30 class range, so their estimated median is 28.8125. The modal class is 21 to 25 since it has the greatest number of frequencies. The standard deviation is approximately 8.95758616 or 8.9576 if rounded off to 4 decimal places. Finally, based on the histogram, we may conclude that the distribution table is positively skewed because the curve is skewed in a positive direction. And that is all for our discussion. Thank you very much for listening.